Okay, so hello, my dear future chartered accountants. Good afternoon, good evening, good morning, everything. I hope everybody is doing great. First of all, can you please confirm that my voice is audible and the PPT is visible? Yes, thank you. So we are doing probability chapter. Let us do a quick revision and then we can go for solving the practice problems or class of problems. Okay, so probability we have broadly two varieties. One is probability calculation, other is expected value calculation. Probability basic formula is chance, likelihood, number of favorable events divided by total events, lies between 0 to 1. 0 is called as the impossible event, 1 is called as the sure event, and the denominator is called as the sample space, all possible events. You can also express in terms of ratio, m is to n, odds in favor, where the first number represents in favor, second number represents against, and opposite, that is the odds against. And some axiotic definition, that is basically set theory formula. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. And probability of A union B, at least one, is 1 minus probability of neither of them. And if A complement, that is no probability of not happening event, the total probability should be equal to 1. Conditional probability, probability of S slash M means a probability of S given that the event M has taken place. The event M which has already been taken place comes in denominator and numerator is going to be an intersection event. And if the events are independent, then the intersection can be calculated by multiplying probability of A intersection B is the probability of A into probability of B for independent events, independent probability. If it is coin problem, number of possibility will be 2 power n, how many times you toss. Dice problem, not die, dice problem, 6 power n, how many dice you use. If you select more than one, then you can go for the concept of combinations. Cards also, hope you remember, we have 52 cards, 26 red, 26 black. Among 26 red, we have 13 diamond, 13 heart, 13 club, 13 spade, and which is divided from 1 to 10. We don't say 1, we say ace. And then we have 11, 12, 13, which is J, Q, and K. And these are the four varieties of cards. All the list I have shown it to you already. Probability or mathematical value of expectation, or E of x, expected value, nothing but mean. You can also say mu E of x, and total of probability is equal to 1 always, and variance of x, that is E of x square minus E of x the whole square. Some properties, E of x plus y is E of x plus E of y, E of x into y, E of x into E of y, and if you have a constant, you can multiply. That is the same property as we apply on measures of central tendency applies for expected value, because this is nothing but E of x. This is just the quick summary of the entire chapter in few minutes. Now we are going to do problems. Along with the problems, which is purely examination oriented, if you have any doubts, we should be able to face that, handle that. I hope people are comfortable till here. Okay, let us go to the problems. Summary like this, what we have done now, I'm also going to do this summary kind of thing for a previous chapter which I've done. I think that should be a good amount for your revision purpose. The statistical description of data, that is measures of central tendency, dispersion, correlation. I'm going to do a summary like this. In a day or two, I will be doing it. For those, if you want to take a picture of this, you can take it down. I'm not sure whether this material have it. This is a good summary for quick revision purpose for day before exams. If you want, you can take a screenshot of this and later you can copy it down. Okay, let's go to the problems. Come to the practice problems, practice or classic problems. If probability of A intersection B is 0, then the two events A and B are, what do you think? If A intersection B is 0, the two events A and B are what? Mutually exclusive, exhaustive, equally likely, independent. Quickly, I'll tell you the meaning of each of these points. Mutually exclusive means if one happen, other does not happen. They don't happen together. Exhaustive means one of the events will happen. So when you add the probability, it will be equal to 1. Equally likely means probability is equal. Independent means the chance of occurrence of one event is not having any impact, influence on chance of occurrence of another event. The answer is mutually exclusive. Many people think it is independent. That is not true. Independent means they may happen together, they may not happen together. In fact, if it is independent event, we do calculate intersection. Probability of A intersection B for independent events, probability of A into probability of B. And for mutually exclusive events means both cannot happen simultaneously, they don't come together. That is what I say, intersection. Intersection means together, simultaneous. What is common to both? So mutually exclusive events are where probability of A intersection B is 0. If you want set theory concepts, of course you are going to learn set theory. When we have two sets, this intersection sets is what? We say A intersection B, common area. But when A intersection B is 0, they are disjoint sets. They look like this. There is nothing common between them. They are called as mutually exclusive events. A bag contains 10 white, 10 black balls that is drawn from it. The probability that it will be white is, can you tell me? What do you think is the answer for this one? Some people think it is 1 by 10. It is not right. It is 1 by 2 because you select white balls. White balls, how many are there? Number of favorable events, 10 whites. Divided by total possible events, black as well as white, you have 20. Or if you want to use the concept of combination, total possible events, you are choosing 1 from any of the 20 balls, 10 plus 10. So denominator is going to be 20C1 and numerator, you are selecting white ball, 1 out of 10. So 10C1. That is when you simplify, you get 1 by 2. Two dice are thrown simultaneously. Find the probability that sum of the points on the two dice would be 6 or more. I can do in regular format by sample space. 36 events, you have to list it out. But do you remember? I had given you one shortcut. Remember the shortcut? We write one triangle like this, where the sum will be like this, or you can write top or below. The sum will start from 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12. Then the probability 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 7, 8, 9, 10, 11, 12. Let me state 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, not 7, 8, 9, 10. 5, 4, 3, 2, 1. That's a probability, okay? 1, 2, 3, 4, 5, 6. Peak is 6 and then 5, 4, 3, 2, 1. It comes down. Probability, the sum would be 6 or more. So we have to consider all the probability. Sum should be 6 or more. So we have to consider from this. Sum is this 6. Probability will be what? 5, 6, 5, 4, 3, 2, 1. So what are all the possibilities? 5, 6, 5, 4, 3, 2, 1. I get 10, 20, 26 I think, right? Total 26. Denominator, when you toss 2 dice, one event is 6 ways, other event other 6 ways, 6 into 6, total 36. So 26 by 36. You can also list out. Sum means 6 should come. 1, 5, 2, 4, 3, 3, 4, 2, then 5, 1. Then 7 should come. 1, 6, 3, 4, 4, 3, 2, 5, 5, 2, 6, 1. Like this you can list out. 26 things you list out. Every chance you are going to miss something. This shortcut technique should help you find the answer in a quick manner. So note down this shortcut if you have not learned earlier. If you have any doubts regarding this, please get it clarified. Done? Okay. Which of the following pairs of events are mutually exclusive? You understand? Mutually exclusive means if one happens, other should not happen. Both of them should not be happening simultaneously. That is, A and B should not happen. The student reads in school, he studies philosophy. He can read school and he can read philosophy also. Raju was born in India and he is a fine engineer. Yes, he can be. In Indian engineers, there are many fine engineers. Ruma is 16 years old and she is a good singer. Yes, a person can be 16 years old as well as a good singer. Yes, possible. Peter is under 15 years of age and Peter is a voter of Kolkata. This cannot happen simultaneously because to be a voter, you have to be at least 18 years. But for you to get married for a boy, 21 years. Basically, it tells you you need more maturity to handle the marriage rather than the country. Anyway, so under 15 years of age as well as voter, both cannot happen simultaneously. Therefore, it is option D. Both of them cannot happen simultaneously. What is the probability that a leap year selected at random would contain 53 Saturdays? Before I do it, you try. Okay, let me do it now. In a leap year, you will have 366 days. And in 360 days, you will have 52 weeks, which means 52 weeks into 7. 364 days, you will have 52 Sundays. Now remaining 2 days. Now remaining 2 days can be of any possibility, which is it can be Saturday, Sunday, it can be Sunday, Monday, it can be Monday, Tuesday, it can be Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, and Friday, Saturday. You see, 7 possibilities are there. 7 possibilities. And out of that, how many would contain 53 Saturdays? Anyway, 52 Saturdays are considered. One extra Sunday we want, which can happen. One favorable event, Saturday, Sunday. It can happen one more favorable event, Sunday, Monday. Out of 7 possibilities, 2 possibilities will give you extra one Sunday to make it 53. So probability is 2 out of 7 possibilities. It is 2 by 7. Leap year. So we get 2 days extra. Oh, Saturday they're asking. Okay, not Sunday. They're asking Saturday. Okay, answer is same. Identification will be different. Saturday, again 52 Saturdays will be there. One is Saturday, Sunday. The other is Friday, Saturday. So the answer is 2 possibilities out of 7 possibilities. So it is 2 by 7. If it is a normal year, then you will have only one extra day. Probability will be 1 by 7. Okay, hope it is done. From a pack of playing cards, 2 are drawn. What's the probability both are queen? You know, numerator should be favorable events. And how many queens are there? In a pack of 52 cards, there will be 4 queens, 4 varieties. Diamond, heart, spade, club. 4 varieties. So you are going to select 2 out of 4, 4C2. Whenever selection is more than 1, we use the concept of combinations. Denominator, you can choose 2 from anything. That is going to be 52C2. So 4C2 by 52C2. I think it's not there in the option. So it's going to be none of this. So numerator 2 queens out of 4. That's why it is 4C2. Denominator 2 cards out of 52 cards. That's why it is 52C. So favorable events 4C2. Denominator total possible events 52C2. If probability of A is 4 by 9, odds against event A is. Can anybody try? Okay, some people are telling 4 is to 5, some people are telling 5 is to 9, some people are telling 4 is to 5, 5 is to 4. So everybody is telling everything. Okay, so when I say 4 by 9, which means if there are 9 possibilities, in 9 possibilities, there are 4 possibility that event is likely to happen, 4 by 9. So 4 is favorable. And remaining 5 is against the events not likely to happen. Now in this case, they want odds against event A. So when it is odds against first number, you express in ratio terms, and the first one should be against. Then the second one should be favorable. So against is 5, favorable is 4, so 5:4. Ideally, you should not write so much. In your mind only, you should think all these things. They asked odds against, so our first number was against, which is the event not likely to happen, 5. Other number 4. If they asked odds in favor, then your answer would have been 4:5. And all the options look very, very close to confuse you. If you're thorough with the concept, then you can select correctly. If an unbiased dice is rolled once, odds in favor of getting a point, which is a multiple of 3 is. Okay. We want multiple of 3. So when you roll a die, what are the possibilities? You have 1, 2, 3, 4, 5, 6. And which are multiple of 3? 3 is multiple of 3. 6 is multiple of 3. So what are the events then? The number of events in favor is 2. Number of events against is 4 remaining. And they want odds in favor. So odds in favor means you write favor first, then against later. Favor are 2 events, 3, 6. Favor 3, 6, so 2 events. Against remaining 1, 2, 4, 5, which is 4 events. So 2:4 or 1:2, you divide by 2 each, so you will get 1:2. Next. We have only 2 multiples and we can get any one at a time. So 1:2. That is same thing only, no? 2 multiples against 4, against 4 only you are telling. You are telling me directly 1:2, but how are you coming in 1:2? You are telling there are 2 multiples of 6 and remaining 4 not multiple of 6. So you are also doing 2:4 only, right? Then you are simplifying 1:2. So directly you are not going for 1:2. I hope you get the calculation. Multiples of 3 are 2, non-multiples are 4, so 2:1. Hope you get the point. Okay. Next. A bag contains 15 1 rupee coins, 25 2 rupee coins, 10 5 rupee coins. Must be the bag should belong to some beggar maybe. And you are going and selecting a coin from beggar bag. If a coin is selected at random from the bag, then the probability of not selecting 1 rupee coin is probability of not selecting 1 rupee coin. So if I say A is selecting 1 rupee coin, And what is going to be probability of A? Selecting 1 rupee coin, that will be 1 rupee coin is 50, total 15 by 25 plus 10, that is 50. That is 50. Yeah. That is going to be 0.3. But the question is not selecting. That question is not selecting. That's going to be complement. So 1 minus probability of A. So 1 minus 0.3, you will get 0.7. So option B. You can also do one more method. What is one more method? You don't want 1 rupee coins. It can be 2 rupee coin or it can be 10 rupee, 5 rupee coin. Or means we are going to do addition. So 25 2 rupee coin. So that we can select, or plus, or you can select 10 5 rupee coin. So 25 plus 10, 35 by 50. That also will give you 0.7. That also will give you 0.7. Next, if two events A and B are independent, then probability of A intersection B equals, for independent events, one event does not impact another event, then the intersection element can be calculated by multiplication. If one event can be done in m ways and another event can be done in n ways, then both of them can be done in m into n ways. So the intersection can be calculated by multiplication for independent events. So probability of A into probability of B, option B. A number is selected random from the first 1000 natural numbers. What is the probability that number so selected would be multiple of 7 or 11? A problem like this, a different number of course, but very similar to this, we had done in illustrations, maybe a session or two back. I hope you don't believe in first in first outs. So please try it. 10th once more. 10th once more, that is the formula, right? Probability of A intersection B is probability of A into probability of B. That's all. There is no other explanation there. For independent events, probability of A intersection B is probability of A into probability of B. That's all. Okay. So illustration level, a question similar to this we had done. So please make a try. Okay. Are you able to do? Okay. So what we are going to do? We should do using the formula 7 or 11. So we need A union B. Probability of A union B, which is probability of A plus probability of B minus probability of A intersection B. Probability of A, that is multiple of 7, B multiple of 11, and A intersection B, multiple of 7 and 11. LCM, 7 and 11, we multiply. So multiple of 77, 7 into 11. So multiple of 7, how do we calculate? Thousands divided by 7. You don't have to list one by one. Simply do 1000 by 7. You will come to the number. 1000 by 7. 152.85. So what you're going to round it off to? Can you tell me? You're getting 152.85. You're going to round off to 142 only. Because if you round off to 143, then you're crossing 1000. It should be below 1000. So I cannot go for it. So it is lower number, round down. Mathematically round up, but you are not doing mathematical. Logically also think. Then multiple of 11, 1000 divided by 11, 103 points. No. So 90.90, which you are round it off to 90, not round up, round down. Then multiple of 77, 1000 by 77, 12.9899, round it off to not 13, round down. We need a lesser number, so it's going to be 12. So probability 142 out of thousands, plus 90 out of thousands, minus 12 out of 1000. LCM is common everywhere. That is 142 plus 90 minus 12. 220 by 1000. Done? Any questions? We had done during illustration, but this should be a practice for. Okay, I hope it is done. Tom speaks truth in 30% of the cases. Harry speaks truth in 25% of the cases. What's the probability they would contradict each other? They would contradict each other. Can you try this problem? Any answer? Okay, let me solve it. Or do you want to try for some more time? Okay, I think let me solve it. It's a simple one but tricky one. Let me solve this one. Two persons are there. They're asking when will they contradict? When they tell different things, they contradict. So first you should list down what are the possibilities. First possibility, we have Tom and Harry. What are the situations possible? What are the possibilities possible? What are the combinations possible? I'll say situation 1. Situations or scenarios. Okay. So in first scenario, uh, Tom speaks truth and Harry also speaks truth. Now please tell me, is there a contradiction? Is there a contradiction? No, right? Both of them telling the truth. When they are both of them telling the truth, there is no contradiction. So, no contradiction. Now, in the second case, Tom speaks the truth, but Harry lies, does not tell the truth. One person telling the truth, other person telling lies, so there is contradiction. People are telling different things. Third situation, Tom lies, but Harry speaks the truth. Here also, they are telling opposite things, so there is contradiction. Now, interesting scenario is this. Tom lies, Harry also lies. These are the simple four situations, right? Like a head, head, tail, tail, head, tail, tail, head. Simple four scenarios. Okay, now you tell me. Tom is also lying, Harry also is lying. Are they contradicting or they are not contradicting? What do you think? What do you think? There is contradiction or no contradiction? Both of them are lying. Okay. Interesting point is there is contradiction here. Why is the case? Sir, both are lying. Both are lying, but will they tell a same lie? Are you getting the point? Truth is one, lies are many. So when they are lying, there is no way they can tell the same lie. That's we can say not possible, at least for theoretical purposes. So only when both of them speaks the truth, then only there is no contradiction. In all the three scenarios, there is contradiction. I'll give one simple example. Let's say you go late to your home. Your parents will ask, or your father will ask, where were you? Why are you so late? You will tell. You don't tell the truth. No, you don't tell. I've gone outside and I was watching film. We went out with friends. That and all you don't tell. What do you tell? We were having group studies. Common lie, right? Common thing. We were having group studies. But you don't remember or you don't have in your mind, your father has crossed your age. He will know what and all you do because he would have done when he is at your age. So he asks, oh, you are in group studies. Give me the numbers. I want to speak to them. So you give the numbers. Your dad will call, first person. Was my son studying with you? The first person tells, yes, he was studying with me. He understood your situation and he managed it. But your father wanted more confirmation. He called one more person. Again, same question. Was my son studying with you? Other person told, yes, sir, yes, uncle, yes, uncle. Just now he left. Some people exaggerate. Just now he left. And the third person, he wanted some more confirmation. Your dad called third person. Is my son studying with you? Other person tells, yes dad, speaking. He's one more extraordinary guy. You understand, right? All are telling a lie, but they were not telling a same lie. Anyway, so both of them lying also, there will be contradiction. So in only one case there is no contradiction, and we have to calculate the probability now. Tom telling the truth 30% of the cases, that is 0.3, and Harry lying, he tells the truth in 25%. Lying means remaining, which is a 0.75, and both of them have to speak together. That is going to be 0.3, and means we multiply 0.3 into 0.75. So contradiction in 3 cases. So 0.3 into 0.75, 0.225. In second case, lies. Tom lies. That is remaining complement. 30% truth means 70%. 0.7. Harry telling the truth, that is 0.25. 0.175. Then both of them lying, that is 0.7 into 0.75, 0.525. What is the total? Point 925. Option B. Please study down. See if you have any doubt. This is 0.3, 0.75. Lies, truth, 0.7, 0.25. Both lying, 0.7, 0.75. Okay. There is one more way you can calculate, and you are observing here, after all there is 4 possibilities, and all the possibilities probability should be what? Sum of probability should always be equal to 1. So what I can do, 1 minus the first situation should give me the same answer, because all exhaustive list we have written down, and the probability of exhaustive events is 1. So total is 1, and if I subtract with the first situation, in all other cases remaining you will get the answer. Anyway, I'll show you that also. I hope you have done till here, and that is more accurate and that is more faster from exam point of view. Okay, done. Shall I show the alternate one? Okay. Alternatively, so probability of contradiction is calculated as 1 minus no contradiction. And what do you mean by no contradiction? Both telling the truth. Both telling truth. And that is first person also tells truth, second person also tells truth. That is the intersection. So first person telling the truth 30%, 0.3. Second person telling the truth 25%, 0.25. And both telling the truth simultaneously. Multiply, intersection, you can multiply. So you get 1 minus 0.0075, you get 0.925. You see how quickly You got the answer. So when in these situations, your brain should tell you whether to list out the regular possibilities faster or 1 minus is faster. That comes by experience if you solve as many problems as possible. You can take down this method also. Probability of contradiction is 1 minus no contradiction, which means both telling the truth. So 1 minus 0.3 into 0.25, 1 minus 0.075, we get 0.925. Okay, next. If two letters are taken at random from the word home, what's the probability that none of the letters would be vowels? What's the probability none of them should be vowels? It can be anything apart from vowels. Okay, so this is selection of two. So when you're selecting two, you can apply combinations. Both are not vowels. Both should not be vowels. None of the letters should be vowels, which means what? Both should be non-vowels. Non-vowel means consonants. So it should not be vowel. What are vowel? You know, A, E, I, O, U. So it should not be O. It should not be E. So it should be non-vowels. Means there are only two letters, which is which is H and M. So only two remaining, and you have to select two. So this is going to be what? 2C2. Available only two. You have to select both of them. So 2C2. A denominator, no restriction. That is all possibility, no restriction. Anything HOME. So there are four. You have to select two. That is 4C2. Numerator with restriction, condition, favorable events, 2C2, 2 out of 2. No restriction denominator, all possible events, 4C2. So 2C2, 2 into 2 by 2 into 1, that is again 1 you get. MCN is always 1. 4C2, 4 into 3, 2 terms. Then denominator, 2 factorial, 2 into 1. So I think you get 1 by 6, I think. 1 by 6. Next. A committee of 7 members is to be formed from a group comprising of 8 gentlemen and 5 ladies. What is the probability that the committee would comprise of at least 2 ladies? At least 2 ladies. So what's the formula going to be? Probability of event A. Numerator is going to be the condition. Number of combinations, number of committees, where at least there are 2 ladies. Denominator, number of committees, anything, total possible event, sample space, exhaustive list. So denominator, number of committees without any restriction, no condition, without restriction. Okay, let us list it out. We have gentlemen, we have ladies available, we have comprising of 8 gentlemen and 5 ladies. 8 gentlemen, 5 ladies. This is available. Then what are possibilities, commissions, possibilities, combinations? Combinations. Total should be 7 and at least 2 ladies. So if I select 2 ladies, there has to be 5 gentlemen. So total is 7. If I select 3 ladies, 4 gentlemen. So total is 7. If I select 5 ladies, then 2 gentlemen. So total is 7. That's all I think. No, I can't select 6 ladies. Available only 5. Or sorry, 4 is there. No, sorry. 4 ladies if I select, there will be 3 gentlemen. So total is 7. If I select 5 ladies, there will be 2 gentlemen. That is total is 7. I can't go for 6 ladies. I can't go for 1 lady. So it is 2, 3, 4, 5 ladies remaining the gents. Compute the combinations, that becomes the numerator. A denominator, committees without any restrictions, that you know very simple. You have to select 7 out of total 13. That will give you the answer. So combinations, let's simplify, let's calculate. Available, this is 13. You have to select 13 out of 7. 7 from 13. 13C7. So 13, you can go till 7 terms. 13, 12, 11, 10, 9, 8, 1, 2, 3, 4, 5, 6. One more. 7. Then 7 factorial. 7, 6, 5, 4, 3, 2, 1. And you know how to do in calculator? I told you 13 into 12 into 11 into 10 into 9 into 8 into 7. Divide by 7, divide by 6, divide by 5, divide by 4, divide by 3, divide by 2. 1716, I think. Actually, option A only you can select because you know 1716, but anyway, let's calculate. Denominator 1716. Numerator, we have to calculate 5 from 8. That is going to be 8C5 and we multiply 2 from 5, 5C2. 8C5, 5C2. 8C5, you can write as 8C3. You know NC n minus r to shorten the calculation. That is 876 divided by 3 factorial 3, 2, 1. 5C2, 2 factors 5, 4 divided by 2 into 1. 560. Second combinations of 4 gentlemen and 3 ladies. 4 gentlemen, 8C4, 3 ladies, 5C3. 8C4, 8, 7, 6, 5, 4 terms by 4 factorial 4, 3, 2, 1. 5C3, I can do 5C2 only. 5, 4, 2, 1. 8, 7, 6, 5 by 4 by 3 by 2. 220 by 2. 700. Then 8C3 into 5C4. 8C3, 8C3 same as SM, 8C5. Okay, 8C3, 876 divided by 3, 2, 1. 5C4 means 5C1. That is 5 you can directly write. So 8, 7, 6, 6, 5, 2, 8. Then last one, 2 out of 8, 8C3, 5 out of 5, 5C5, sorry, 8C2, 5C5, 8C2 is 8, 7, only 2 factors, 2 into 1, and 5C5 is 1, this is 28. Five 60 plus 100 plus 280 plus 28, 1568. Yeah, 1568. This is the total possibility, 1568. And so numerator 1568, denominator 1716. So you get option A. So please write it down. Take your time, it's okay. And see if you're able to understand. No shortcut for this. Questions like this do take some time. Can't help. You can do by one more method. I'll show you that also. But in the exam, you should judge which is straight away possible, which is complementary is possible. I'll show you that also. But anyway, first you take down this. Once done, please let me know. Please confirm. Okay. One more method what you can do, instead of doing more than two ladies, you can do a complement. Then subtract one from that. I'm not doing it. I'm telling it. You can try later. Less than two ladies means what? It should be less, more than two, opposite. Opposite means it should be less than two. Less than two means it can be zero lady or it can be one lady. So if zero lady means all seven are gentlemen, one lady means all remaining six are gentlemen. So you will get two possibility only. You find out the possibility like this. That is, you get 8C7, 5C0, 8C6, 5C1. That you simplify and do the total and do 1 minus of that. The complement method. You will get the same answer. You can try it out. I'm not doing it. I hope you can try it out. That will be faster. Please try it down later. Okay. Uh, let's take a quick break of 5 minutes. Then we'll move further. Take a break of 5 minutes. Okay, let's move on. Mr. Roy is selected for three separate posts. For the first post, there are three candidates. For the second, there are five candidates. And for the third, there are 10 candidates. What is the probability Mr. Roy would be selected? Now, for this, first you should tell me, should I calculate? There are three posts, okay? So, A union B union C, should I calculate? Or probability of A intersection B intersection C? First, you please tell me this. Which one of them should I calculate? Union or intersection? What is the probability Mr. Roy would be selected? Does he have to select in all the three posts? Definitely not. You have to select only in one of the posts. So it is union. I hope you are able to understand that first step. And then question comes, three sets formula, set theory. Three sets formula is probability of A plus probability of B plus probability of B minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. And intersection elements are not given. We only have three posts, and three candidates means probability is 1 by 3. Five candidates means probability is 1 by 5. And 10 candidates means probability is 1 by 10. So we can calculate probability of A, B, C. How do we calculate intersections? When no informations are given, we say that they are independent, and independent events probability can be calculated. How? Probability of A intersection B is probability of A into probability of B. But this method is a long method. Instead of this method, I'll follow complement method. What is complement method? Probability of selecting in one post, probability of selecting at least in one post, selecting at least in one post can be written as 1 minus probability of not getting selected in any post. You understand, right? Probability of either is 1 minus probability of neither. Complement. So probability of at least in one post, probability of not getting selected in any post, which means failure in first post, failure in second post, failure in third post. And we need a failure in all the cases simultaneously. So we multiply. So what is the probability of you selecting or getting selected in the first post? There are three candidates. You are one of them. 1 by 3 you can select it. But not getting selected, 2 by 3. Remaining two people get selected. And in the second post there are 5 candidates. You are one of them. Remaining 4 people only get selected. You are not getting selected. 4 by 5. And last one similarly 9 by 10. You multiply all of them, basically means you are not getting selected in all the posts. First also failure, second also failure, third also failure. Multiply all of them. 0.45. 0.48. Okay. Point 0.48 and 1 minus 0.48 will give you 0.5. The options. Okay, next. A card is drawn from two well shuffled pack of cards. Please focus on this. Institute is very clever. They give the data of number in words. TWO. They could have given symbol 2. They could have given like this too. If they give in examination, the numbers you can easily catch, but the words you usually miss. Institute knows very well. So to make you miss these things, they'll have a question like this. So be very careful, especially careful when they give the data of numbers in words like TWO, ONE, FIVE. Instead of giving the symbols, they give the words for numbers. There, be extra careful. The probability that at least one of them is an ace is. Now, at least one of them is an ace. So, what you can do possibility, first one is an ace, second one is an ace, first one is not an ace, second one is an ace. First one is an ace, second one is not an ace. See, like this, if you list out the possibility, three possibility come. Instead of that, what you can do? You can simply do 1 minus none of them are aces. That is more easier, right? So probability of at least one ace, I can write as 1 minus probability of none of them are aces. None are ace. Probability of at least is 1 minus probability of none. Probability of either is 1 minus probability of neither. Complement method. Hope you got the point. So 1 minus probability of first one is not an ace, second one not an ace. So first one not ace and second one not an ace. First one not an ace, second one also not an ace. So what is the first of all condition? Without any condition, you're selecting from, okay, first one not an ace. How many aces will be there? 4 varieties. So you can select 4 out of, or 4C1 out of 52. No, it should not be an ace. So 48 out of 52. It should not be an ace, remaining 48. And multiply. Second also should not be an ace. And you're selecting, now tell me, division, divide by 51 I should do or divide by 52 I should do. In the second ace, denominator, should I do 51 or 52? It will be 52 only. Why? Because I'm selecting from different pack, not from same pack. If I'm selecting from same pack, then yes, 52 was there. I took one, remaining 51. But here, from one pack, I took one. And from another pack, I'm taking one. So in both cases, denominator is 52. I'm selecting one only. So 48 by 52. Here also should not be an ace. 48 by 52. So 48 by 52 into 48 by 52 is a 0.85. You get 0.85, that is 0.15. And which one 0.15? You can try from the options method. You don't have to simplify, waste of time. Don't simplify to come to the fraction. If it comes, okay. Don't spend timing simplifying it. Let's look at the option. 1 by 169 is 0.005. Not the option. 25 by 169. 0.147 looks the closest one. Let's do third one. 2 by 13. 0.1538. I think that will not be the number. I think this is more closer. 48 by 52 into 48 by 52 minus 1. I think 0.147 is more closer. If you actually calculate, you'll understand. Therefore, 2 by 13 is also not the answer. So option B, 25 by 169. So learn this technique. Probability of at least one, probability of union, A union, B union, C is 1 minus none, 1 minus A complement intersection B complement. Probability of either is 1 minus probability of neither. Probability of at least one is 1 minus probability of none of them. Quite a few problems you have solved so far. I hope you are comfortable. Please practice these problems again even after the class. Okay, I'll go further. If you're still writing it down, let me know. I will keep going to the next one. If you want me to hold it down, you should let me know. I'll stop. Otherwise, I will be moving to the next one. In a group of 20 male and 15 female and 12 males and 8 females are service holders, what is the probability the person selected at random from the group is a service holder given that the selected person is a male? Given that one event has already occurred, do you know what is the concept we have solved? I will tell you without using formula, but still, can you recollect? What is the probability of one event given that another event has already happened? What is that concept? Are you able to recollect? Anyway, it is called as conditional probability. Probability of A slash B, probability of A given that event B has already occurred is a probability of B denominator, a probability of A intersection B in the numerator. Anyway, but let's try to understand without that. Simple logically only will apply. We'll get the answer for this one. In a group of 20 males and 15 females. So group, we are having 20 males and 15 females. Of that, 12 males and 8 females are service holder. So in 20 males, 15 are service holder, I'll say SH. Remaining 5 are others, not service holders. And in females, 8 females. So in 15 females, 8 females are service holders and remaining, that is 7 others. Okay, what they're asking, what is the probability person selected at random from the group is a service holder given that person selected is a male, given that person selected is a male. So you know it is a male person, it has to be out of males. How many males are there? 20. So denominator has to be 20 out of 20. Given that person selected is a male, out of 20 males, he should be service holder. What is service holder? It's going to be 15. So 15 by 20, that is 0.75. Answer is none of this. You take it down. Some people, I'm sure, might not be convinced still. So we'll ask a different question from this only. Let's see if you're able to answer that. But before that, first you take down this. Oh, 12 males. Sorry, I wrote 12 males. Oh, sorry, my mistake. It's not 15. 12 is it? Sorry, I wrote wrongly. 12 males. Thank you for clarifying. So 12 means this is going to be remaining 8. This will be 12 by 20. I'm sorry. It will be 12 by 20. That is 0.6, right? 0.6. I wrote 15 wrongly. 12 males. Out of 20, 12 are service holders. Okay, I hope it is done. Okay. I'll ask you a few questions based on this only, because I usually observe that this conditional probability, somehow people are not very comfortable. So I'll ask few more questions. Let's see if you're able to answer it. Okay. In this question, they said, given that selected person is a male, what if they told selected person is a female? Can you tell me what would be the probability then if the person selected is a female? It's going to be 8 out of 15. Female are 15 and 8 out of 15. Not 8 out of 20, 8 out of 15. Because given that person is a female, female total is 15, 8 by 15. I hope you're able to get it. Okay, if I ask you one more question now. Let's say, given that person selected is a service holder, okay, I have given the person selected is a service holder, what is the probability of selecting a male? Listen to my question carefully. Don't write it down. Listen to me and try to answer. Use your mind, nothing else. I have given you the event which has already taken place. The person selected is a service holder. Out of that, what is the probability of selecting a male? Now, given you service holder, now service holder means how many total service holder given? Denominator, here we'll have 12 service holder and 8 service holder. So, it's going to be 20. Out of the 20, what is going to be a male? That is 12 by 20. 12 by 20. Okay, hope you got the point. I'll ask one more last question, then I'll go for it. Suppose, given that person is non-service holder, what's the probability of selecting a female? Listen to my question carefully. Given that person selected is not a service holder, what is the probability of selecting a female? Now, what is the service holder? 8 in male, 7 in female, totally 15. Out of the 15, what is the probability of selecting a female? That is 7. So 7 by 15. I hope you are able to get the point. I think I'll go further. Hope you are comfortable on this one. A player has 7 cards in which 5 are red, and of these 5, 2 are kings. A card is drawn at random. What is the probability? It is a king. It is being known that it is red is. Okay. So player has 7 cards. In the 7 cards, 5 are red. They are given that, okay, 5 are red. And of these 5, okay, 5 red means obviously 2 are black. And of these 5, 2 are kings. So of these 5 red, 2 are kings. And remaining 3 must be others. Okay. Now look at the question carefully. Whichever event they have already given, that will be denominator. Whichever event already happened, that will be denominator. Now, which event already happened? It is known, it is red. From this data, how many reds are there? In this data, don't look at the entire pack of cards. In this 7 cards only are there. In how many reds are there? We have red, only 5, right? It has to be out of 5. Out of 5, what's the probability? It's a king, and king is 2. So answer is straightforward, 2 by 5. In fact, there's nothing to calculate, nothing to write. Simply read the problem, choose the option. So some questions will take more than 2 minutes. Some questions you will have answer like this in a fraction of a second. On an average, you should know how much time you should take for question. You will have 100 question in exams and you are going to write it in 120 minutes. So 120 minutes by 100 questions. You will have on an average 1.2 minutes per question on an average. Some will take more, some will take less, but you have to maintain average this much. Like after 30 minutes, you should assess yourself in an exam. Am I going fast or not? Or if you're practicing. 1.2 minutes means how many seconds, can you tell me? This is after this problem, but this kind of planning required for you to practice. 1.2 minutes means how many seconds? It's not 80 seconds. 1 minute 60 seconds, correct. Point 2 is not 20 seconds. It is you multiplied by 60. 0.2 minutes multiplied by 60. You get 12 seconds. So, to read the question, to read the solution, to solve, to look left, to look right, to check whether your answer is right, do all those verification, and then to mark the answer. In total, you get 72 seconds for every questions in math stats logical reasoning exam. So when you practice problems or when you're writing mock exams, try to practice this, or when you're solving a problem, keep it in mind. In class, I'll take more time because I have to explain. But when you are solving, initially you will take time, but over a period of time, make sure your timing is 72 seconds on an average. Some questions more, some questions less, that's fine. But you have to maintain an average of 72 seconds. Anyway, I'll go further. In a group of students, 30%, 40%, 50% failed in physics, chemistry, and at least one of the two subjects respectively. They failed in subjects, respect. If an examinee is selected random, what is the probability failed in physics? It is known that he failed in chemistry. So let's draw a circle kind of thing, two circles. In a group of students, failed in physics. So this is failed in physics, which is 30. And this one failed in chemistry, which is 40. And what is 50%? At least one of the two subjects. That means all the circles put together, union sets. First circle and second circle together, put together, it is 50. Now using this, can you find out the intersection? 30 in physics failed, 40 in chemistry failed, and 50 in both of them. So 30 plus 40, 70 should have come, but 50 is coming. That means 20 people is common. 30 plus 40 minus 50, 20 should be common. Or if you use the formula also, you can do. Probability of A union B is a probability of A plus a probability of B minus a probability of A intersection B. If I keep this to left side, probability of A intersection B is a probability of A plus a probability of B minus a probability of A union B. That is 30 plus 40 minus 50, that gives you 20. Logically also you can calculate, a formula also you can calculate. Now what is the requirement? What is the probability he failed in physics? What is the probability he failed in physics given slash that he failed in chemistry? What is going to be formula? Whatever happened will come in denominator, probability of whichever event occurred, probability of C. And numerator is going to be intersection, probability of physics and chemistry, that is 20 out of 40, option A. Write down carefully. Again I repeat, somehow people are slightly not comfortable with this concept. So do it slowly. completed. Any doubts? Whichever event took place, that should be denominator. That is the key point. Given that, no, known that, whatever is known, that will come in denominator. Okay, so if you have understood, please confirm that you have done with this one. Can I go to the next problem? That okay. So now let's see if we're able to answer the next problem, which is very similar one. In fact, same question, requirement is different. Same question. In a group of students, 30, 40, 50 failed in physics, chemistry, and at least one of the two subjects respectively. If an examinee is at random, what is the probability he failed in chemistry? It is given that he failed in physics. Can you try? I'll put the box once more. This is physics, which is 30. This is chemistry, which is 40. This intersection we calculated 20. Now, what is the probability he failed in chemistry? Known that he failed in physics, known. That means it has to be out of the first box. So, denominator is 30. Out of that, how many have failed in chemistry also? That is what intersection 20, 20 by 30. Nothing to write actually, just the answer only you have to take it. No calculations, just observation. Next. Same question again. In a group of students, 30, 40, 50% failed in physics, chemistry, at least one of the two subjects respectively. If an examinee selected random, what's the probability he failed in physics? If it is known he failed in one of the two subjects. This is interesting. Read it once more and try to tell me the answer. Actually, there is no diagram required. Question only has all the data. Given that he failed in one of the two subjects, what is out of one of the subjects? At least one of the two subjects, at least one of the two. They have given 50% already. Out of 50, how many failed in physics? That is, physics is 30. So 30 by 50. Answer is option D, 30 by 50. I hope now you got some confidence in these conditional probability problems. Technique is very simple. Whatever is given, that should be in denominator. That's all. Everything else you can easily identify. Whatever given, whatever event happened, that should be in denominator. At least one of the two, it is given at least one of the two subjects. That is 50%, denominator 50. Out of that, who have failed in physics? 30, 30 by 50. Okay, I hope you got the points. I'll go further. Okay, I'll make one small correction in this question. Let's see if we can think of it. What is the probability failed in physics if it is known that he passed in chemistry? Can you think of this question? Can you think of it? Let's see. He passed in physics. Okay, I'll just draw the diagram. First circle, physics 30%. Second circle, chemistry 40%. And common, 20. What is the denominator now? Given that he passed in chemistry, 40, that is, I'll just color it. This yellow color represents people who have failed chemistry. People who have failed. Okay, this is what people who have failed. But we don't want people who have failed. We want people who have passed in chemistry. Passed in chemistry means I am going to draw a different color, blue one. It's a light blue. That is outside this. outside the circle. Okay, I'll just select it outside the circle, the blue region. Including physics also. Only thing, it should be outside the circle. Okay. Now, outside circle means how many people? This are all percentage terms. So, the first circle represent 40. Outside 40 means denominator should be 60. Most of you have got it right. Numerator, you are having, I think most of you not getting it. It is given that he is failed in chemistry. Out of these 60 people, how many have failed in physics? Many people told the 30. You are not right. Because 30 includes 20 also, right? I don't want this C circle at all. It has to be outside C circle. Means, can I say like this? You have passed in chemistry, failed in physics means what? You failed in physics only. I'll repeat once more. You have passed in chemistry, but you failed in physics, which means you failed in physics only. So out of 30 people, 20 people have also passed in chemistry. Remaining 10 people within this blue circle, they failed in physics only. Answer is going to be 10 out of 60. I hope you are able to get this one. You should not include those 20 people. Many people told 30. 30 includes those 20 people also who failed in chemistry, but they are given. It's given they passed in chemistry. So those 20 people cannot come. They failed in both. Amazing persons. Extraordinary people. So those 20 people I should take it out. From the 30 people, I want who failed in physics only because they passed in chemistry. So failed in both, I should take it out. Are you able to get that point now? 10 by 60. Because I have not got anybody not given the had not given that answer. How is it 60? How is it 60? Because they said 40% failed in chemistry, but what is given? It is given they passed in chemistry. So if 40% fail in chemistry, it means 60% people should pass, right? 100 minus that. Because total is percentage. We are discussing in percentage. 100 minus 40. Right? Okay. Okay. I'll go further. There are three persons ABC having different ages. The probability that A will survive another 5 years is 0.8. B will survive another 5 years is 0.6. C will survive another 5 years is 0.5. The probability that A and B, A intersection B, will survive another 5 years is 0.46. B and C will survive another 5 years is 0.32. A and C will survive another 5 years is 0.48. What's the probability that all these three persons survive another 5 years is 0.26? Find the probability that none of them survives another 5 years. Now, first of all, my dear friends, here are the events independent or not independent? In this case, ABC, are the events dependent or independent? What do you think? They are not independent. Why they are not independent? You know, if they are independent, A into B should be what? The probability of A is how much? Probability of A is 0.8, probability of B 0.6. So A and B If they're independent, A and B I can multiply. 0.8 into 0.6, I should get 0.48. Am I getting 0.48? A and B is 0.46, not 0.48. Are you getting the point? When the events are independent, A intersection B is A into B, not happening here. Or other way around, understand, when they give you intersection, events are not independent. From exam point of view, I'm telling you. Hope you get the points. So we need find the probability that none of them will survive. So probability of none of them survive can be calculated as 1 minus probability of at least one survive. And at least one means what? Union. So probability of A union B union C. At least one means union. And three sets. How do you calculate the union? Probability of A plus probability of B plus probability of C plus probability of A intersection B. Sorry, not plus, minus probability of B intersection C minus probability of A intersection C, then plus overall intersection, common intersection, A intersection B intersection C. This is the formula for three sets. Two sets they can ask, three sets they can ask. They will not ask four sets in exams, don't worry. So two sets formula I should know, three set formula I should know. So 1 minus probability of A surviving 0.8, probability of B surviving 0.6, probability of C surviving 0.5, probability of A and B surviving, given A and B surviving 0.46, B and C surviving, given 0.32, A and C surviving 0.48. All of them are surviving, that is 0.26. Had they not given these intersections, then you could have assumed as independent events. Keep it in mind. When they don't give you intersection, you can calculate intersection using independent events. But when they give you, they are not independent. So 1 minus 0.8 plus 0.6 plus 0.5 minus 0.46 minus 0.32 minus 0.48 minus 0.26. So not last one is plus 0.26. It is 0.9. So 1 minus 0.9, 0.1. So there is 90% probability at least one of them will be there. Only 10% probability all of them not surviving. In next 5 years. In next 1000 years, probability is 100%. None of them would have survived. Okay, fine. Okay, so we have quite a few more problems. I think when we meet tomorrow, we'll continue it. Hope you have taken it down. I will stop at this point. Keep revising. Keep doing the homework problems also. We'll see you tomorrow at same time. Till then, take care. Bye-bye.